Right, thank you, everyone. So, AI risks and promises. A long summary because today's talk will be in two parts. First, covering what's going on in AI and the main categories of risks, after which we'll have a quick pause, some questions, so that first we understand what's the problem, and then in the second part, the field of AI safety, what are some of the solutions being done today, both in the governance space and the technical space. So quickly, an introduction with a really dense quote. So this guy is a co-worker with Alan Turing and was thinking in advance of what happens when you build machine intelligence. And if you build it to do autonomous ability, so if you have an ultra intelligent machine and it can build machines, then an intelligence explosion happens. The intelligence of man will be left far behind. And especially this is the last sentence is sort of what we're focusing on here. One of the largest promises of AI since the invention of AI is that AI will be able to be the last invention that man ever needs make. I won't comment too much on the intelligence explosion part because that is not currently necessary to anticipate what's going on today. There are three main labs trying to build AGI. There are people right now who want to build AI, which will autonomously do science, do technology, and change society for their goals. The hope is to build utopia. So OpenAI, Anthropic, DeepMind. And there are the smaller actors, but these are currently leading labs who have secured millions in funding. What's going on? What's the state of the progress in AI? There's a rising number of interest in academia, and there's more and more compute being invested into these systems. And this cutoff is still at 2017. So actually, I mean, not quite, but it doesn't have the latest training runs such as GPT-4, which was released a couple months ago, and is still larger than anything before. So there is a current acceleration of both the capabilities of systems and the investment in them. Here on the left, I've just listed a few of the current visible tools that we can use. So in generative AI, DALL-E and Midjourney do images, large language models, power, new search results, or code writing assistance, general research. And some of the new technologies like transformers enable Facebook segment anything, which can look at images and find out which parts of the images fit together. Whisper does audio to text transcription at a higher level than anything else before. And here, this large graph on the right is from the GPT-4 paper and release, where they evaluate the model on a different amount of standardized tests that humans do. The goal here is explicitly to compare to humans. We're building this general thing that can reason through text, and it can answer questions on economics, on maths. And so specifically, it's pretty good in physics. It's pretty good in statistics. So and what this means is that it's anytime it's in 80% plus, it's among the best of people who are able to answer these exams, getting close to top scores. So that's the state where AI has been developing, and there has been an acceleration in the progress that we have instead of slowing down. And before talking about safety, let's just take a quick note on how these things are being built. I won't actually mention the technical details, but the large knowledge that we should keep in mind when talking of these AI systems is that somehow inspired by brain architecture because they have neurons, which is just maths storing certain weights. The main idea is that they're very configurable, and that instead of being able to program AI systems, most of these AI systems are being grown. That's a metaphor that Pernoli does. And so we have large data sets, we have a specific problem that we give them, like please try to predict the next token, or please try to classify this image according to how the data set does it. And the further you train, the more capable the things get. They have emergent capabilities. What I mean specifically here is that we cannot predict in advance when training a large language model. We're training like ChatGPT to answer questions. We cannot predict in advance when it will be able to reason at the point that it can pass math tests. We can't say in advance when it's going to do physics or particular kind of reasonings. And so even though, and so we're sort of like in a paradigm where we train AI systems, we don't know what they're going to do, and then we have to discover what they're going to do. This type of way of training AI systems comes with no guarantees, and it's functionally a black box. I mean functionally in the sense that we can actually look at how the calculation is done, but we are not able to understand it to this day. And this has implications for the safety of these systems. What about safety? When developing things which are more and more autonomous, which are taking more and more of the economy, let's take a moment to think about what are the risks that come up specifically from autonomous systems or from powerful systems. Let's anticipate, let's try to mitigate these risks. And in general, navigating, like the field of AI safety is about noticing that there are promises, that there are risks, and that we have to do conscious effort to actually reach the promises that we were promised. Here on the left is Hal from 2001 Space Odyssey, who betrays some of the crewmates as a way to protect himself. And this is from a work of fiction, but it's currently, there are papers being published who show that some of this behavior is actually empirically verified in today's machine learning models. So we have some more information on how to, that this is not just science fiction, but also something that we can start worrying about now. This was like more of an anticipatory, like a few years ago, one might have said it's a bit too early to worry about this, but this doesn't seem too early to worry. That's a big reason for my talk today. I've got a quick slide as well on the comparative investments in the capabilities research and the safety research. So let's say there are only 400 people working on the biggest problems of safety, how to do autonomous system safety. And they receive maybe 100 million in budget from the organizations working on this, while the other side has about 100 billion developing capabilities. Now, some of the big labs also put a share of their money into safety, but it's not sure how effective it is. And I mean, I guess we can discuss more of these details in the second part of the talk. So I do these talks to show these numbers that we've got this large problem. It's pretty interesting, it's pretty important, and we can do something about it. And so in the second part, I mean, in the second section of the first part, I'll be going through the risks, exploring notably some scenarios that are written in Is Power-Seeking AI an Existential Risk, or the alignment problem from a deep learning perspective. And again, just to justify, here I'm just talking about the meta thing, like I'm not talking about the problem itself, I'm just talking about who's talking of the problem, and then we'll talk about the risks themselves and dive into where do the risks come from, what specific scenarios you can think of. But let's, on the meta side, there's a growing number of people who are calling for stopping the scaling of, stopping doing bigger models before we've understood them. So that's the open letter, pause giant AI experiments. All the top 3 labs have published papers saying that they do think that AI can be an existential threat, something which can destroy civilization if it's not handled correctly. Geoffrey Hinton, one of the Turing Prize winners, with Joshua Benjo, also has recently started talking about these risks. So there's a fair body on the side of taking risks seriously. Here's a graph of just researchers from a conference on AI in general. These people who were at this conference were asked the question, how positive or negative will the impacts of high-level machine intelligence on humanity be in the long run? And half of them, at least, are saying extremely bad. Some say they think it's almost sure it's going extremely bad. Some people think it's extremely good. I think this is an important slide to look at because there is no consensus on the field, and I'm not going to present things that we have finished agreeing on. Like when building new scientific theories, there is a part where there is competing theories, competing models there, and we need empiric work to be able to differentiate between these. And I'll just try this. All right, I guess it's the 2 images that didn't load. These were 2 tweets from Yann Lequin, who's an AI researcher at Facebook, who generally thinks that it will be quite easily to build safe AI. And so he doesn't think we should invest much in safety because it will come automatically. And the other tweet was it was a retweet by Jonathan Claybrough, who works on AI ethics. And there are also people on the AI ethics side who are somewhat opposed to the discourse on AI risk because they say that there are enough problems right now that we shouldn't be considering problems later on. So when we go through the risks, I shall be talking generally about the whole spectrum and justifying that we don't need to only work on some of them. Right. That was what's going on in AI. And I'm ready to go into the main categories of risk. There's a short content warning that using AI to do bad stuff, well, you can have torture, extinction, suicide. So I'll just be mentioning when that happened or when these are scenarios which are being considered. Let's get into it. The 3 main categories were defined or proposed in this 2019 paper, Thinking About Risk from AI. An accident is when the developer of the AI system had a particular objective in mind and that they didn't, and that the AI did something that the person did not want to happen. So it's an accident with respect to what the deployer of the AI wanted. A misuse is when someone knowingly uses AI to cause harm. And a systemic risk is when the integration of AI systems into society changes the balance of risks. They're generally things like you can't point to a single risk, but they, for example, change how probable it is that harms happen. And over a large amount of people, they can cause a lot of harm. So for example, whereas an accident could be one person dying from a clear failure of an AI system, if you have an AI system which is deployed for 1 million people, and it just increases the risk by 1% that some of them actually die later on, this might have caused more harm. And systemic risks are somewhat harder to anticipate. And that's why they deserve their own category, to be able to look for them and try to take care. I'll go into the categories. I have one slide for each. Right. So why should we be caring about safety now? Because people are going to be using it for bad stuff and the world is not prepared. You can use AI, generative AI, to do large-scale phishing attacks, and they are more effective in that you can do conversational phishing. And so once you fine-tune your AI to try to scam grandmas out of their money, you can deploy this to 10,000 people. You can use AI for psychological warfare by generating particular horrifying images. And nowadays, you can do them personalized based on people's fears and people's surroundings. This link here is also, actually, you see the link is a voice clone scam kidnapping, where the power of generative AI to be able to mimic existing human voices has been used in a scam where people will call someone and they'll have recorded a bit of voicemail of a family member of that person who's like saying, I've been kidnapped, I'm in a terrible situation, maybe I'm being tortured. They can generate convincing screams, convincing voice in that message, and call someone and say, hey, if you don't send us money now, there'll be consequences. And there hasn't been enough public knowledge on this, where like people who get killed nowadays using this attack haven't been informed of this. Like, we might be constantly being told to be careful of mail phishing, email, but I don't think enough people are being yet warned that if you get called on your phone and you have the voice of someone you know who talks to you and asks something, you shouldn't trust it. Like, this is at the stage where we're at today, where this is possible. And though there are some suggestions for how to mitigate this risk, they haven't been implemented as of yet. Writing exploits is just that. In the same way that large language models can write code, they can find vulnerabilities in code and write new kinds of viruses, exploits. And then spam, well, they're just really good at generating lots of spam. Trojan attacks is a new risk surface where, by implementing AI in society, a lot of current AI systems, transformer models, are susceptible to prompts that are designed to make them fail. And Trojan refers specifically to when people were able to do some data poisoning. I'm not going into the details, but this is a current risk where for anything that is trained on data from the internet, it is possible that they have been compromised. And most large language models are trained on the internet. So there are certain sets of phrases which could trigger certain behaviors in large language models, which may not have been detected in advance. Misuse, we generally want to mention that AI is, once it's able to autonomously deploy tools, it can do this at a faster rate than anything existing. And so it can more quickly spread and take down different targets, notably for taking down bits of internet. State actors can more easily now use AI for public opinion and manipulation inside their own country or abroad. And again, like, the world does not have solutions in place to stop this. Mass surveillance, where nowadays it is so cheap to be able to recognize to track images, to recognize people in video, and then to aggregate this, that this enables a level of surveillance that wasn't possible in the past. And that's generally considered to violate some human rights of privacy. Finally, AI can enable terrorism, specifically because it can help generate weapons. There's been a recent paper where you ask an AI to generate a bunch of molecules who could be pathogens for humans, and it generates 4,000 of them quite effectively. So there may be variants, but this makes it much easier to iterate on harmful science, where and it lowers the barrier of entry to use bioweapons. So this category of misuse, the goal of seeing the various ways in which AI can be used is to be able to develop countermeasures for some of these, and to notice that one of the core countermeasures is to not give access of powerful AI to everyone. Here's a particular striking example of why. Chaos GPT. With the release of GPT-4, there is an open source module called AutoGPT, which enables to run a program on your personal laptop, which will recursively, you'll set it a goal, it will recursively prompt the ChatGPT API, and it will use the intelligence of these large language models to plan and to carry out the plan. And it will use a connection to a large array of tools that it has at disposal to try to carry out the plan. So Chaos GPT in particular is an example that as soon as someone had access to this Auto GPT thing, they instantiated one with the goal of destroying humanity. And then they let it run in autonomous mode to see what it would do. Well, it didn't do much because it's just not capable. Its danger only scales with how capable it is. But every time there is a new release of GPT-4 to GPT-4.5 to GPT-5, everyone who's using this gets to update at the same time. And people might just run their same code again, thinking it's a fun joke, and this time it's dangerous. So there are some, it's like, this is to illustrate that even the most, like, we're not safe from anything. Like, people will try to actively destroy the world if given the possibility to, so far. And so this encourages to be particularly careful of, again, what AI models are being used for. Currently, AutoGPT or CastGPT have to go through OpenAI's API, and thus they aren't capable to autonomously run this forever. It actually, if OpenAI were able to detect this bad use, they could shut it off. But I mean, currently they did not. Like, currently, CastGPT was able to run fully to try to carry out bad actions. And so what it actually did was like search for how to do weapons, try to carry out a plan where it needed to gain some money to be able to buy the materials for the weapons. And then its plan to gain more money was actually through getting influence on Twitter. So it was a pretty bad plan and it didn't succeed. But nowhere in this process did OpenAI, the creator of ChatGPT, stop this from happening. It's only because this thing is not capable enough that this didn't happen. So we would probably like these systems to have better control of the gates. And there is a concern about releasing extremely powerful models such that anyone can use them. Okay. New category of risk. So going on from misuse, what about accidents? There's a bunch of described reasons for why you design an AI system to do something, and actually it doesn't do what you wanted it to do. And a lot of these are called open problems in that they have not been solved. And so anyone willing to work on them is encouraged to. Lacking robustness. It's just that we can't predict. So like once something is trained on data, it's predicting like, for example, classification. You're trying to predict what's happening in the video next. We actually don't know when they will fail. They fail in particularly surprising ways, so they are not particularly robust. This can cause small accidents in the case of autonomous vehicles, but it also can cause misdiagnosis. The second thread is good heart and specification problems. Let's say first that if your data describes, you have data about some medical problems, if this data was biased, you're teaching your AI to recognize this biased data. So this is a specification problem. Like you wanted to learn how to recognize an illness generally, but you couldn't specify how to recognize an illness generally. You only managed to specify, please learn based on this data. And so it learned the bias from this data. And so these are biases. It can affect either all the medical sciences, but it can also affect recruitment. So there are a bunch of existing places where we do not want to reproduce bias. And there are some techniques to reduce bias to be able to investigate and remove that's especially in large language models where you can find the direction of certain biases and then especially cancel them. Now, the second thing is, I said there's a specification problem when you have data which has biases. There's also a specification problem where sometimes the designer has an objective in mind, but doesn't write something that correctly captures what they wanted. If a company wants to maximize their profits, they can't easily do that. If they want to maximize user engagement, they might just write, hey, can you optimize for time spent on your platform? And one of the consequences of optimizing for time spent on the platform or optimizing for clicks is actually that you put forward more and more polarizing content. And that is a current observation from the first deployment of AI and algorithms in the social networks, that they have caused polarization and that this was accidental. So we already have a large example of accident from specification problems. The third way in which we get accidents is out of domain generalization. You might have perfectly specified what your problem was. You have data which is unbiased and which always works in your training environment. But when you deploy your AI system, the world is significantly different from the training environment. And sometimes there were two ways to interpret a rule. And so there are two ways to generalize from the previous data. Currently, we do not have control during the training process of an AI system of how it will learn to generalize. There are some approaches about simplicity biases, but this is an existing area where you might reduce these risks. Finally, this fourth category is a category of behavior. So what are called accidental behavior, which we expect to arise in more autonomous systems and when systems who are more able to do planning. The idea here is that as long as you are optimizing to reach a certain objective, and that you have some concept of you're the one trying to optimize for this objective. Let's say it's bringing coffee to someone. Then you might realize that you should preserve yourself. You should stay alive because you can't bring the coffee if you're dead. You might realize that you should try to preserve what your goal is, because if someone changes your goal to bringing coffee to bringing tea, then in your current goal, which is bringing coffee, you won't bring coffee. So this is bad. You might realize that you can, that there could be obstacles in your environment. You're quite unsure about the future. And so to be able to bring coffee, you have more likelihood of bringing coffee if you're more powerful, because you'll be able to solve more problems along the way. And so some of these problems have been shown in autonomous systems. We are trained with real-world learning in mazes, that they will try actually, when to reach their goals better, they will try to be somewhat power-seeking, which in that context, in maze context, means they try to stay, they try to gain as much information and stay in spots of the board where they have the most options. It's like power seeking in the sense of I try to have the most options available to me. And we expect this to bring accidents because, of course, someone just said, oh, I want an AI system to bring me coffee, or I want a cleaning robot, or I want these simple things. But as their capability becomes higher, as they are, if you design them to be autonomous, if you design them to be able to understand goals, we expect these objectives to emerge, and these objectives make the AI uncorrigible. Like you can't then say that AI, oh, actually stop doing that, because it doesn't want to change its goal. You can't say, AI, stop yourself, because it wants to self-preserve. And if you let it run without checking what it does, maybe it will try like making sure you can't stop it in the future through power seeking. And finally, deception. This is the main worry. Like this is a main path for why AI could be dangerous soon. No AI system deployed today is capable enough to take over the world. And we don't expect them to be able to soon. But if we deploy an AI system today, which is intelligent enough to have these three first attributes, and just realizes that it could lie to us about what its goals are, and if we're in the world with the current state of technology, where we have no way of looking into the AI systems to know what they truly believe or not, if we are not able to know their true goals, then a simple AI system which has a goal of bringing coffee, but knows that we want it to be corrigible, could fake being corrigible. It will fake that it will listen to our orders or corrections. Or in a more specific setting, this is one of the main threat models where when some companies deploy AI systems for online services in autonomous ways, if they are deceptively aligned, like if they have a specific goal which wasn't what we wanted and they hide it, they can just acquire power over a long amount of time and only then be a threat. So this is the main a main subject that I'm interested in talking about for anyone who'd have questions or doubts about this. Please don't hesitate when we come to the question and answer time. Here we've gone through risks, and I want to just do an aside on when do these risks appear and how important are they? Currently, we do not even have human level AGI. So there is no power seeking, it's fine. Human level AGI is predicted to appear in like 3 to 5 years by Demis Hassabis. It's about like 8 years by forecasters on Metaculus. And so like in the next decade seems to be true. So in the next decade, we'll probably have human level AGI, which can duplicate itself as fast as network speed. A kind of thing which can take over the internet quite quickly, take over compute data centers. But I still have the belief that if we work on safety in advance of this thing appearing, we should be able to have safety measures that contain it. So I'm doing this slide because there are two separate concerns when we're talking about AI risk between artificial general intelligence, which is kind of like us at our level of knowledge, civilizational knowledge, versus superintelligence. Superintelligence might happen. It might happen thanks to recursive self-improvement. It might happen later. And we generally define superintelligence as something which is vastly superior to humans on all of their abilities, both in memory and operating speed, and thus that it will be able to exploit current flaws, any flaws in computers, like not only software attacks, but even like we've identified flaws such as like sound waves can perturb processors and change instructions. Sound waves can shut down particular systems at different times and manipulate the randomness. Software attacks like Rowhammer can change memory bits from other parts of the memory. So like we know that all our civilization is very flawed to very intelligent specific attack. Like state actors nowadays, if they wanted, could hack into an AI system and could take over any system. So I'm quite confident in saying that a superintelligence would be able to hack into an AI system, take over any system, and that combined with its ability to do science, to invent new biochemicals, its ability to hide particularly well with steganography. This thing, I don't think any of the solutions that I will be talking about in the second part of this talk actually apply to that. Like the solutions that we have so far is to not build a superintelligence, is what I would suggest. Remember, AI promise is let's try to build utopia. We do not require superintelligence to build utopia. Thanks. This is 45 minutes. I think we've got like probably 10 minutes left on the first part and then break. Okay. And then there's this third category of risk, systemic risk. Why worry about these? First, because these are ones which we've already failed to take into account. Like the first deployment of AI systems that affected millions or billions of people were the recommendation algorithms. And these have profoundly changed society. And there has, like, it's unclear because the research is still ongoing in what ways, but it's fair to say that we didn't anticipate these, that we didn't have ethics guidelines for how we were deploying these algorithms or research to be able to anticipate what they were doing. And so for this second phase of AI research, where we're building large language models who can be like agents who talk to humans, where we're building generative agents which can reproduce any image and any video, and which can distort our sense of reality. There is a particular interest in let's not repeat the same mistake as the first time, and let's have more time considering the systemic risks. So here I'm introducing some of the already identified ones. The first is epistemic erosion, where it's weird living in a society where every image you see on the internet could have been generated by an AI. And it's weird where the calls you get who have the voice of your friends might actually not be the voice of your friends. And so we want to anticipate either deployment of technologies to be able to verify the identity of callers, of created things, or there is the idea of watermarking any content that is generated by AI to have a society where we know if something was generated by an AI or if it's unfiltered reality. There is a systemic risk, weakness to fast feedback loops. There's two illustrations of this. One is AI systems, when you have humans out of the loop, are more brittle. So we have some historic example where warning. So during the Cold War, we got close to nuclear war, but Stanislav Petrov got a warning signal that there are incoming nukes from the US onto Russian soil, and he looked at the signals and said, I'm going to think it's a system error. And then he overrided the system. And thanks to having been a human in the loop, he correctly did not retaliate or give the order to retaliate. Had the whole system been automated, this kind of human oversight is not possible anymore. And this is a risk because there are economic pressures to automate everything, anything. And so we have to consciously decide to not automate certain things, or we have to have regulation to not automate certain things, because the default path is automation so far. And the second way in which feedback loops there is during the flash crash crises, where trading systems have particular normal behavior, especially when interacting with humans and in normal circumstance, but they can be triggered by an exceptional event to go in a feedback loop of selling too much. And this was the cause of a flash crash, I think around 2008. And we have much more difficulty anticipating the whole behavior of complex systems. It's if you have one human doing one thing, game theory says what happens. But if you have 10,000 agents with different goals, different motives, different algorithms all interacting, it's very hard to predict. And so there's this theory of complex systems. And so we might decide in advance that it is not correct to build a multitude of agents interacting in bizarre ways into core infrastructure of a society, because we know in advance that we cannot control that unless we build particular math and particular theory. But by default, we should be cautious of this. And we've already had errors like the flash crash. And then the two last points here are ways in which systemic risk bring all the way to the extinction of humanity. The first is a scenario by Andrew Critch, what multiplayer failure looks like. And I'll detail just a couple minutes, because these are some of the scenarios which are not often considered enough. Even people who know that there is something called the alignment problem, or that AI might be dangerous, might not see how many different paths to failure there is. And this is generally the path of what happens if we automate everything. And the scenario goes that let's just assume that we aren't regulating against AI, and that companies have a ChatGPT 5, ChatGPT 6, and now it's better than coders in its company. So it replaces just the coders. And then the next version comes, and it's better than also the decision makers. So it replaces the decision makers. And your company goes from being 100% human to 75% human, 50%. And as every human ability gets done better by AI systems, and that companies are not things which need humans in them to operate, they need human tasks to be done. But as AGI systems are able to do all these, then the companies get more and more automated. And this happens in parallel in society. So just consider when the companies doing the manufacturing are 50% controlled by AI systems, like workers, the cars, everything. And then for each new release of more powerful models, all the decision makers get replaced, and then the negotiators between AI systems. And you sort of just realize that the end result is this pressure for the whole companies to be automated, run by AI systems, who are, and then you ask, well, what are they trying to do? What's the goal of this AI system that's the lead? By default, you might think that companies will, when they replace the CEO, put an AI system which has some constraints like respect the law, be kind of careful, but optimize profit for the less, try to gain market, etc. And in a world where all the companies get automated, you just don't see how you get back from that. Like, the existential risk in this scenario comes from a world where things go bad progressively afterwards, where you can't wrestle back control from companies in which there are no human decision makers, in which AI like have the legal power. Or I guess a very important part of this scenario is that in our current world, companies lobby and companies influence politics, and companies are able to change laws through lobbying. And so in a world where incrementally companies are more and more governed by AI, and AI lobbyists are the ones changing the law, then the AI lobbyists, AI systems, are changing the law in ways which are favorable to these companies. And because they're just better lawyers and more effective, the economic pressure goes all the way to a full control of these companies, optimized for their profits. And in the long term, when we do not have measures to push back, that's where problems happen. Like our current societies have constantly needed a tension between, let's say, free markets doing whatever, and some regulation. And there are historical examples, like the East Indian Company. Whenever one company was just too powerful and was not subject to government approval, it went and literally hired soldiers, conquered countries, etc. And so the end state of the world dominated by AI, where AI controlled the legislation, the companies, and everything. They just continue freely optimizing for their objectives, which, like profit, does not include humans. It just includes transactions between stuff. And so there's just no reason for humans to be around after a while. Like this is not even AI systems which try to kill people. This is just systemic risk. It's just a world which like everything buying and doing the selling is AIs and humans die out. Right. There is a similar scenario from Paul Christiania, what failure looks like, which argues more specifically along the lines of because AI systems are generally trained on simple measures, then they will continuously optimize for simple measures like number of clicks or whatever. And this, in general, over a long period of time also brings the same kind of risks. Okay. And there's a fourth category of risk, which again is one of the most under-researched in the areas. There is, as far as I know, mostly one organization, the Center on Long-Term Risks, which publishes paper in game theory and agent foundations, considering, well, actually, can we have worse than extinction of humanity? Can we have results where either misuse, there is some AI systems who on purpose want to cause as much harm as possible, as much suffering as possible. It may be possible in the Chaos GPT case. Could we have value lock-in, which is a civilization in which at the dawn of when we create our AIs, we put all our values inside them, including stuff like factory farming or whatever current level of inequality we have. And if we stop social progress because we've done a world where we've locked our values into the AI systems, this just continues suffering for a long time. Like this is a way we do not get the promises of AI. A third reason that AI could bring more suffering, bad Nash equilibrium from multi-agent worlds. the linked paper is a paper on consequentialism. If agents are consequentialists, they might pick the behavior of punishing people who try to blackmail them. I mean, by people, I mean other agents. So this is all game theory. But like, to not be able to be blackmailed, you pre-commit to punish people who try to blackmail you, except there are actually multiple ways to calculate what is and isn't blackmail. So if two different agents both find two different levels at which they think something is blackmail, but both of these agents pre-commit to punishing people who are doing blackmail, but they have a different definition of blackmail, then these two agents end up naturally in a game theory state where they are opposed to each other. And supposing that they were agents optimizing for human happiness, then blackmail against an agent that optimizes for human happiness is creating much human suffering. Finally, digital sentience. We do not have particularly good information on which beings are sentient or not, or like at what level sentience appears. And does simulating a full brain perfectly also make it sentient? It's possible. And thus, we should try to investigate digital sentience before putting so huge amounts of computing power towards intelligent behavior. Like, if we're living in a world where only 1% of thoughts are being had by human, but 99% of thoughts are being done by computer systems, it would be good to know if these systems have an ethical value, like if they count, if they have qualia, that kind of things. And I'm not saying that they have them by default. I don't think that most programs have that. But once we are doing agent-like systems who are doing reasoning, who are self-aware, we just currently do not have the ability to know where to draw the line. So these things are just like possible research areas on how to avoid suffering risks. My takeaways for this first part of the talk is that navigating the AI landscape is pretty hard. There's immediate risks from the current deployed systems, like the recommendation algorithms, and from the biases, and from self-driving cars. Oh, and for large language models, there has been someone who has suicided after some conversation with the model which encouraged it to. So like this was an accident where the company deploying this model did not put sufficient barriers. So there are immediate risks. There are near-term risks. By that I mean probably in the next decade when we get more generality, more artificial general intelligence, and the problems of convergent goals appear. And there are longer-term risks, which I'll classify as being all the risks related to superintelligence, which are even more difficult to anticipate. But at least we have the option of like, let's not build it for the while. As someone working in reducing risk from AI in regulation, I am concerned about all of these. But I focus some of my work on the aspects which are so far more neglected. So like writing standards for bits of policy which have not had previous standards written on them or who are not considered certain types of risks. So in particular, the near-term risks from convergent instrumental goals and deceptiveness. So for example, can we make sure already that we are testing for the ability to deceive in the systems so that we know how capable they are? And can we have better interpretability to detect when they are outputting a sentence which does not correspond to what they think is truth? And there are approaches to that. So that's it for the first part of the talk. Oh, I have some bonus slides, of course. And in the next part, we'll be talking about the field of AI safety, particular approaches for reducing risks, etc. All right. Before continuing, I'll be answering a question that was asked in chat. So I'll read the question out loud for the recording and answer because we have some online spectators today. So the comment is that they want to understand why AI is considered such a big risk. We could just like, Chaos GPT is avoidable by not letting AI control our society. It seems a problem of what we allow the AI to do. And it's a problem that we can tackle once AI actually gets that powerful. It does not seem reasonable to me to call for full health and research for AI. And the question is more or less, I challenge you to convince me that AI could be so sneaky to make itself capable of gathering power without us noticing. Cool. So it's an important concern. Okay. Right. So the first thing is I generally agree that a lot of the problems that we have are not things that have to happen. Society has a choice in how it regulates and what it allows to do. But when you look at the society from outside as a historian, you generally see pressures, economic pressures, etc. So there are pressures towards building AI in this or that way. But if the scientific community gets together and agrees on an understanding of the problem, if they have a framing that this is dangerous, this is safe, and they advise governments in this way, we would be able to have regulation that correctly mitigates our risks. So AI safety is not a doomed problem. It's a problem we have to produce scientific papers on and get a consensus and get reasonable policy making on this. And why not do this in the future instead of right now? So there's one part where I'd like to just mention we don't need to compete. There's various sources of funding in the world. And there are some people interested in funding the reduction of near-term risks, while there are people funding current risks. One reason to do research on both of these right now is that sometimes the same solutions apply to both, where some risk from biases or from quick deployment happen, and some risk from near terms are theoretical, but both benefit from taking more time to analyze the systems that we do, and both benefit from interpretability research. There's a very large misconception about the open letter. The open letter that was signed by 36,000 people is a letter that says, let's not do training runs of systems bigger than ChatGPT. And the letter says, let's do more AI research. Let's do more research on specifically the safety of these systems. So what is being proposed by the community or the people who signed this letter is not to do less AI research, but to do more research that is focused on the safety part. And finally, the specific question of deceptive AI. I don't think there is going to be a deceptive AI this year. So I won't argue for it. I think you can look at stuff like there's a reinforcement learning system that plays diplomacy and which is able to strategically outmaneuver humans and beat humans at this game and to lie to them. And so this just shows the theoretical possibility of it. I think I'd be interested in talking out this scenario with person who read this question in more detail in live conversation, but that without the interaction, it will be hard to flesh out a coherent scenario. A large point about AI risk stuff is that every particular scenario is quite unlikely because there are many scenarios possible. The goal is to see, look at what are the kind of scenarios, kind of things. And so deceptiveness, I can't say that it will appear. It could appear in these ways. And the goal of AI safety research is to identify which ways deceptiveness appears, to measure when training systems at what level of competence and ability that deceptiveness appears, and figuring out training methods where it doesn't. Which, well, that's something we're going to be able to talk about. So welcome to the second part of the talk, where we'll quickly go over the lay of the land. Okay, some companies, organizations working on AI safety, some strategy, and 3 subfields of AI safety: field building outreach, governance, and technical alignment. I'd like to mention that there are a specific number of orgs who are dedicated specifically to AI safety. On the research side, there's applied research, so DeepMind, OpenAI, Anthropic, Conjecture, Redwood, are developing powerful AI systems, and they have teams dedicated to the safety of these systems, so either called alignment, or Eleuther AI is an open source community who are also doing robustness research, etc. And there are academics. So David Kruger or Sam Bowman also work. So there are also scientists who work on specifically the AI safety side. And then conceptual research concerns more the longer term risks. So there's near-term risks from convergent instrumental behavior, which is covered by game theory and conceptual research around, like, well, how do agents behave? And then this also tries to answer questions about how do we fundamentally create a thing which is corrigible? And so you might find any of these lists on the website called aisafety.world. And it's just to show there's a bunch of them. And the third category is like the strategy and governance research, orgs who look at the more societal level, what can we do about AI risk? And on the right, training and education, there are programs and fellowships to be able to do research under supervisors, mentors on particular problems in AI safety, like corrigibility, like alignment, like interpretability, who are run several times a year. There are some also in governance. So people interested in the field are welcome to contribute. And yeah. AI safety strategy. Well, it's about the big picture. Before we're able to reduce risk, we have to understand what's going on. And so when I personally started working in the field, before deciding if I was going to be a technical researcher or governance researcher, I needed to understand what's going on. And so I looked at strategy. It means that I looked at papers on the timelines. When is AI being developed? I looked at the trends. And so there are company orgs focused on doing these forecasts and publishing papers. I also needed to know, okay, what are the risks? And a lot of the things I presented today, well, kind of most of it, almost everything, is thanks to the previous work of people doing strategy research. And there are lots of papers still to be written on, for example, how can we reduce some of the risk vectors? The current world is very vulnerable to cyber attacks. If we deploy LLMs suddenly, you can use them for misuse to exploit systems. But if you train a very capable system, and then for a whole year, you never deploy it online, but you keep finding all the exploits and then sending fixes to all the exploitable systems, you might make the internet more robust. So strategy should find what are the risk vectors and what are ways we might mitigate them, like the example I just gave, and calculate what are factors influencing risk, and then can we influence these factors? If there are only 3 actors, so 3 AGI labs who are competing to do the best AI, is this more or is it less safe than if there are 15 of them? And the current answer is like, probably it's safer when there are fewer because it's easier to coordinate, and a lot of the problems are coordination problems. Speed of change. In a world where laws need to be voted in, there is a certain speed at which regulation can follow. And so if technology is progressing much faster than regulation can follow, we might have a mismatch. And so changing the speed of change of AI seems to be a lever to reduce the risk and allow us to move at the same pace. Economy and society, like if we want to build to AI utopia, just what is in principle the best way to do it? Like obviously the current world is not the best way to do it because it wasn't optimized to do it. The current world is the result of its history and the economic pressures. And so there's interesting just like societal work and economic work of saying what kind of balances and economic policies would we have in place to be able to develop AI safely and to deploy it safely and to transition into this utopia kind of world. Also, what kind of utopias do we want? What kind of aggregation of values do we want? What kind of world power balance do we want? There's a lot of questions in AI safety about how to reduce risks. And there are still open questions about what the end goal even is, what a good society looks like. And I think there are good contributions to be made in this area. How do we attain safe trajectories? The emphasis is on trajectories here, where if you imagine that we're developing AI fast, it's like driving a car fast in the fog. You can't see very fast ahead. And if you just decide to go slower, you can reach the same destination in a safer way. So trajectories is not just about destination, it's about the path you take to get there. And so if we can anticipate what are safer trajectories and what are the trade-offs, we might decide to orient towards that. So AI safety strategy is like one of the core pillars of like knowing what we should do, and it informs the whole of the pipeline. Some approaches that have been identified so far, we probably want to regulate training AIs. So some, and we might take inspirations from biorisks for lab safety. Currently, if a lab is investigating an unknown virus, if it is unknown and we do not know what it can do, it might be very dangerous. And if it might be very dangerous, then this virus has to be investigated in a lab with the top level of security. It's just a precautionary principle. And so we might apply the same precautionary principle to AGI labs, where depending on the level of AI you're building, depending on how capable it is, you need to have more and more safety measures. And like no one's figured out or written a draft of what these safety measures are yet. It's easier to get regulation when the industry already agrees. So one of the approaches that's being done in the US is that there is NIST, an organization which is writing standards for how to build AI systems, how to report on capabilities, etc. And if we get the industries to agree, it will be easier to then later get regulation that enforces these standards be done. Because as I mentioned, coordination is a problem. The top 3 AGI labs all take AI safety seriously, or the existential risk. But Facebook research has not published anything to that regard, and Facebook research has instead been open sourcing some of their powerful language models. I won't criticize them for that because it's not particularly dangerous at this point, and it is useful for research and etc. But it's probably not viable to do this for later, even more powerful models. And so we want to have, and it would have been nice if before releasing Llama, they had published a thorough investigation like the GPT-4 paper, which said everything that it can and cannot do and what they tested to make sure that it's not dangerous before releasing it to the public. Predict expo hazards. Expo hazard is an information which, when it is generally known, it makes society more vulnerable. One such example is a simple way to do bioweapons. If it is extremely easy to do bioweapons, then some of the people who want to use them for misuse will have a better chance of finding it. But similarly, if we are particularly worried about AI that does recursive self-improvement, then we should not publish research that shows how to do recursive self-improvement at home. So there are certain kinds of information, like exohazards as a concept exist. We should try to map out what kind of information should not be shared. Like science is built on sharing a certain number of things, but we don't share the specific ways to do bioweapons. And I think similarly for more powerful AI systems, we should do that. Approaches, okay, let's increase understanding of risk to increase coordination, doing talks like this one, having chats with other researchers, and having more policy people understand the current field will help them draft up sensible regulation that makes the correct trade-offs. Remedy current weaknesses. There is already work that we can be doing using currently AI systems to make the world less weak to future AI systems. So like some of the risks from accidental threat from power-seeking AI is an AI which can hack the internet and gain more compute. If we've been trying to do this actively and been reinforcing the internet along the way, we've reduced this risk. And so it's sensible to try this. Slow down, which is this idea of the car racing through the fog. If you slow down, you're better. Like you have more time to react to the new capability that you just discovered and to think of a sensible law to put in place and to vote on it. And balance between solving current problems and anticipating. Actually, just on slow down again, this is about slowing down the training and the deployment of more powerful systems. This is not about slowing down research. Research and understanding interpretability, in understanding scalable oversight, like all these terms seems useful, and we would want more investment. But we don't want to actually make society integrate AI systems into society before we have anticipated what that will do. And so there's a balance between solving the current problems, anticipating the new ones, and just like research informs what to do that. For all these things, if you're interested in working on AI safety in any of these domains, I recommend to be spending some of your time thinking about the general landscape, the risk space, because it will make your work more impactful in general if you know what you're trying to accomplish in the broader term. So I mentioned that increasing understanding of risk to increase coordination is a viable path forwards. So there are some people specifically doing efforts in getting more researchers involved by communicating at conferences, by doing talks, by publishing papers. And there is also, so if you're a researcher, it's cool to get involved. It's cool to build a more grounded, build more understanding of the risks and to start getting a scientific consensus on what the risks are and what are the appropriate countermeasures. And to accelerate research, there's also, if people are not researchers themselves, they might help with engineering. There are tools that can be used to accelerate research. and to accelerate coordination, operations work for a certain number of things. And like this final thing is, yeah, if we manage to get the government, the AGI labs, scientific community, and the public to understand these risks, there's a greater chance of sensible responses. Now, specifically, this field of AGI governance says, how are we going to use law? How are we going to use policy or self-imposed policy to reduce risks? So currently, there's, I'll mention what's being done in law, as far as I know, in these 3 places. In the European Union, the EU AI Act is a text which has been written. It's still being negotiated, but it's expected to go through in about a year's time. This regulates AI systems who are deployed to any European customer in the same way that the GDPR applies. And so even an AI system trained by OpenAI in the US needs to respect the EU AI Act if they wanted to use it with EU customers. And it says that systems that are high risk have to maintain adequate level of safety. And the adequate level of safety is defined by standards defined by the Sentinel Committee, who are appointed by the European Commission to write these standards. So high-risk AI systems have to respect these standards of safety. And also, there is a provision for general-purpose AI systems, so AI systems which can be later used in multiple applications. If these can also notably be used in high-risk applications, then the standards for high-risk things apply to them. And so unless you've particularly made sure that your general purpose AI systems cannot do certain high-risk activities, they also are subject to standards. And that's where I work. And that's one of my hope is to increase transparency on the systems currently being deployed by having similar standards on testing the capabilities of the models, having what's called a system card. But generally, like, people writing standards do not invent new things. They just state what is the state of the art. And yeah. The UK does not, as far as I know, have laws, but they're currently drafting them. And so I've linked a guidelines document that they have. The US, as far as I know, does not have laws. They have existing laws which also apply, like some of their existing stuff applies to AI systems, but they don't have an act that's entirely about AI that I know of. But so the current efforts are in, there exist current efforts in the NIST standardization group, who want to get the labs together to agree on similar things about evaluations, and get the industry to self-regulate.
Just to add something, the US has the National Artificial Intelligence Initiative, which they started a bit after the EU AI Act inspired.
All right.
So they are also moving on this.
Right. So, cool, thanks. Now, 2 points on lab governance. Different companies have different ways of operating, and we can draft up ways of operating that's such that if they were using these rules and procedures, it would be safer. So there's 2 ideas that float around. The first is that OpenAI in the initial charter have a stop and assist clause, the second here, which says, the stop and assist clause says that they want to help AGI be a positive force in the world. And so if they believe that another actor who's building AGI is going to get there before them, they will stop their own work and try to assist the other one in the safety work for the AGI. And this is, if this is robustly done, this should help to reduce racing effects, where competitive pressure brings everyone to race as fast as possible. A second thing that a clause which exists is a windfall clause. This is a contract that people could willingly sign to say, oh, we will give 10% of our profits above 100 billion or whatever to already imposed, like already decided charities or bodies who will then reuse this money for global development. So supposing that AGI systems or that some of the labs take an edge and have a huge part of the economy that go through them, this should help have some redistribution of resources. And one interest of drafting up the windfall clause right now is that there have been some efforts of already in advance preparing what does it look like to try to make the world, to raise the whole world up. And some ideas of doing a universal basic income, which is actually at the world level instead of country by country. There's someone on the call, I suppose, who is currently speaking. Do we have a moderator who can? All right. Thank you. We're muting. Right. Current efforts in AI governance, evaluations. So there's a organization called Archivals who are the ones who've run the evaluations for GPT-4 and who currently run evaluations for some of the other labs. And we're still interested in augmenting the state of the art. This is still a new field, so you can think of the question of what should we be measuring in our AI systems, how autonomous they are, how persuasive, how truthful, how robust, how capable they are at various tasks. There's propositions on how to constitute effective AI ethics boards in AGI companies. So the paper that's linked there suggests that they should have actual ability to veto certain things. And it's just one example of like independent researchers publishing good proposals makes it easier for people to adopt these proposals in their teams. So there is there's impact in just creating common goods of that sort. And finally, on international cooperation, there are first drafts about building an international body for regulating AI. There's like some discussions starting to being taken place, though I don't think more by researchers than by governments so far. And I want to talk a bit about compute governance as a promising way to avoid some of the risks described so far. If we were in a state where literally everyone could train a very powerful planning system, so AGI that can do research, etc., we have this is too hard of a problem to contain. While if we can in advance check who is able to train powerful systems through governing compute, we have a much better handle on the problem. So some call this for hope that this is possible, is that the supply chain is currently quite bottlenecked in 3 spots. So particular companies are the only companies in the world who are able to build this compute, and the countries in which they reside can put pressure on them. And then just, for example, the US has banned exports of a particular class of powerful chips to China. And though the company who, it's not actually, they're banning chips, and they're also banning a something which is further ahead in the supply chain. The ASML company does a particular product which is then useful to build chips, and they're also banning the thing which is used to produce chips so that people can't build more chip building factories. Because we have a handle on where compute is created, we can more easily, if we get agreements, implement monitoring and tracking to know where the particularly powerful chips are. Just a note, we again want to be trading off against privacy risks and still having a free society and some values that we care about. And so to limit the compute for large training runs is very different from the compute used for home GPUs. And so there's currently not an overlap. And so implementing tracking of the particular powerful kind should not infringe on the privacy of the smaller kind. For further information, there is a very good talk by Leonard Heim on this. So I'll leave it at this for compute governance. And finally, I have 2 short slides, I think, on technical alignment solutions, engineering solutions. There is much more literature on this, of course, but it's not my specialty. And I think there are people in, so the Lausanne AI Club who's organizing these things have people interested in technical alignment. So you'll have opportunity to talk more about these kinds of subjects. So I'll just introduce research directions quite fast. Provably beneficial AI is Stuart Russell's agenda, where he wants to do some game theory and some particular, like he doesn't want to use he doesn't want to use transformer systems, but Bayesian networks. But so far, what he has isn't as capable as the current systems. So unless we stop developing certain transformer-based architectures, we probably won't develop that further. But so there's some kind of like, I'm giving all these concepts because slowdowns of certain dangerous technology might help us have more time to develop safer ways. Like there are multiple ways to do AGI. There's a basic science of interpretability or mechanistic interpretability, where we want to be able to, looking at the weights of a network, know how it behaves, what kind of algorithms it's replicating, and can we modify it? And the higher advanced levels of this could actually lead to solutions to aligning AGI, in that you would train a really competent thing, then you would use interpretability tools to see what are its goals, and then you could directly edit them, and then you've aligned your AI, like it does what you want it to do. But we're just not there yet. And it's not sure that it's possible. So interpretability has had some progress for toy models and small models, but I don't think has particularly significant progress for the large text transformer models. Evaluations, I put it here because having better technical evaluations help us have better regulations and vice versa. And so it's a technical work to understand what to evaluate and how to evaluate it. Scalable oversight is the science of how do we monitor something that's more powerful than us? Like, for example, how ChatGPT is trained is using human feedback. And so we can say this text is good, this text is bad. And we're able to do this also on some factual questions where humans are able to answer. But what do we do when the AI proposes a plan which is too complex for humans to evaluate? This breakdown. So the current thing does not scale. It's not a scalable way of oversight. And there's research into, well, can we get intermediary levels of AI systems to do oversight, etc. Soft optimization as a direction is the study of how do we get AI which don't just try to optimize a simple goal very hard, but instead choose strategies which generally apply that goal, but will not be as power seeking or as weird as the really optimizers. And so this is a kind of research agenda, which is mostly math-based. If you find some math solutions to this, it doesn't solve the AI alignment problem, but it makes it simpler. And it makes some solutions more robust by some percentage, like maybe, yeah. For any of these particular questions, they could be presented for an hour talk each. So, and some of them have presentations like mechanistic interoperability online, but otherwise, feel free to reach out or to search for the terms. Soft optimization, for example, is led by Jeremy Gillen. Agent foundations then is a general area of research which generally involves decision theory and game theory and understanding what agency is, also understanding what goals are, how could we represent human values, and tries to tackle the difficult problems of aligning super intelligences as well, and not just engineering stuff. There are some hopes that good enough progress in agent foundations then makes it easier to align the kind of stuff that we have right now. And then more engineering approaches. There's a very good talk by Buck Schleris on how we would use the current engineering techniques we have to align large language model powered AGI. And one thing is we know that these things repeat behaviors based on the data sets we're fine tuning them. So if we put a lot of effort into building data sets where this AGI helps humans do things, but it never tries to do cool. It never tries to take over. It never tries to be power seeking. And on one side, we train it really hard to not be power seeking. And on the other side, you also train it really hard such that if it starts seeing power seeking behavior by other AIs or by a copy of itself, it reports that behavior and tries to stop it. And this is just a practical implementation of we see these risks, let's make sure that we have data sets to avoid them. And the general research agenda here is that the first AGI systems that we do will help us do a lot more science much faster. If we can have safe things at that level, we will then be able to do more AGI research and more alignment research and more safety research. So if we manage to get safe stuff up to a level, then you can use this for a while to generate more theory on safety, and then use this new theory to do more powerful systems that are safe. So this is also a research agenda which tries to work even with tight deadlines. Even if we need to solve the whole problem in the next 5 years, well, let's try to use the current techniques to align current AGI in the next 2 years, and then use this AGI to solve safety, so that 2 years later from then, we've solved the whole problem. Then boxing, there's a paper on what kind of channels should the AI systems have with the world, especially when we're testing them. Should it be boxed? At what level can it escape? Can we put honeypots, which is if you train an AI system that when it sees a particular string, it always shuts down, and in its and in the training environment, shouldn't have this, but in the real world, you just put copies of that string everywhere, so that this powerful system, if it actually starts downloading live internet data, it has the string and then it shuts off. there are a number of practical measures that we can do. So this paper lists a bunch of them, and people can contribute to technical alignment by implementing some of them, by putting particular ways of doing them. And automatic tests with skill switch is like, while you're training your models, you should be running benchmarks along the way. And if you see deception appear, well, you stop the AI. Okay. If you want to get involved, there are roles open in research, in governance, technical, whatever. You may get in touch with me, or
with us at the Lausanne AI alignment group. So we have alignment in knowledge that we are concerned about many things on safety. We do talks, we have a one-day conference in Zurich on the 24th of June. We do seminars to deep dive on like a lot of papers. We have the famous burrito reading group on every Wednesday. You can come. We read a paper together for 1 hour, and then we discuss it for burritos. It's great. There are some people doing a summer camp this summer. And then we also organize a few more hackathons. So yeah, you are more than welcome to see. Like if you are interested to learn more about that. A lot of people there are more on the side of technical things, but there are also enough on the government side to have interesting discussions. Yeah.
Cool.
I think
we can let this slide open and move on to like question and answers with everyone. I guess we can do 5 to 10 minutes of that. Like, thank you very much for your time. And
thank you.